Welcome to the video for lesson 4-8. This will be the final lesson for our 050 class. So we are almost there. You've done the prep skills, hopefully, and you'll notice finding the slope if you have 2 points is pretty important. Also combining like terms, we've talked about that before. We're going to use those things in this lesson. And you've read, I hope, the learning objectives and the introductory part of the lesson. Kind of gives you an idea what we're talking about. The lesson today is kind of based on business models, so hopefully you can use that to understand linear equations. So start off with, we'll go into a business problem in the group work. So most of the group work is based on this problem. If you haven't done that already, read through the problem and then answer question 1. Restart the video when you're finished with that. Okay, so we've got business, 2 years of sales records, and she's found that she can sell 400 jars per month. Of bath beads when she prices them at $12. When she lowers the price to $10, she sold 480 per month. So at the cheaper price, more people want to buy them. Kind of makes sense. She raises the price. Some people just don't want to pay $12. So question 1, we're assuming that relationship is linear. Write an equation that relates the price P to the number of jars of bath beads sold. And what we are going to do here is notice that we have 2 points in a relationship. Jars per month, dollars. So we've got P to be the number of jars. P is the price. X is the number of jars sold. So instead of Y equals MX plus B, we're doing P equals MX plus B. And they give us a good hint here. Start by writing ordered pairs. Okay. So if X is the jars sold, we put the X first. So 400, comma, $12, and 480, comma, $10. That kind of helps us see it in terms of mathematics. In terms of the story, we can see there are 2 points. Now I have my X and my P. When I put it in the ordered pairs, hopefully I'm seeing that. Hopefully you're seeing that better. Don't worry if you're not. That's okay. So a lot of different ways we can go here. Best thing to start off with, though, is to find the slope. No matter what you do, it's good to find the slope. So M equals, you notice in the prep skills, they said change in Y, difference in Y, divided by change in X or difference in X. That triangle is the Greek letter delta. It has the D sound. That's why we use that for difference in Y, difference in X. So difference in Y, I'm going to make this point 2, this point 1. I'm going to have 10 minus 12. And you'll notice in this problem, it's going to be important to make sure we put things in the right place, because we are actually going to end up with a negative slope. And I knew that immediately from the story, because when you decrease the price, you sell more jars. When Y goes down, X goes up. Or when x goes down, y goes up. Anyway, so 0.2 is 480 minus 400. So I end up with negative 2 over 80, or negative 1 over 40. You could do that on your calculator if you'd like. That gives me my slope. So question is asking us, I want to make sure I'm reading the question right, write an equation. So we do need to write an equation. They weren't just asking for the slope. After I did all that, I couldn't remember for sure exactly what it said. Anyway, we have our slope. We now need our equation. Some of you may want to use the point slope form. So y minus y0 and that y0 because that's a known value. Y is a flexible value, and I'm just deciding I need to do p instead of y. So p minus p0 equals m times x minus x0. So I'm going to say p minus, I'm going to take the 12 for my p0, which means that I need 400 for my x0. The alternative is to go ahead and write what we know. P equals negative 1 over 40 times x plus b. I'm going to separate that from my slope. Then I can plug in a number. Now that I have an equation, I need to find b. I'm going to take that same point. I'm going to say 12 equals negative 1 over 40 times x, which is 400. Once I choose the 12, I know my x, 12 for the price, I know my x is going to be 400 plus b. So I still haven't written an equation. To write an equation, I need to have my p and my x without plugging anything in for them. But I need to plug in my m and my b. So I need to find my m and my b. I found my m. Now I have an equation where I can find my b. I have negative 1 times 400 divided by 40, which gives me 10, negative 10. 12 equals negative 10 plus b. I am going to go to my equation solving tools. I will add 10 to both sides. Hopefully you realize if you're going to subtract 10 from b and get 12, you know that b is going to be 22. 10 minus 10, negative 10 plus 10 cancels out. You can cross it out or you don't have to, it doesn't matter. But we know that b equals 12. Okay. If I come back over here, I'm going to finish out the point slope form, because the point slope form, I have an equation, but I need to get it in the p equals mx plus b form. So I have p minus 12 equals negative 10. Oh, sorry. I'm going to do this in order. Negative 1 over 40 times x plus 10. Okay. And here I get my equation solving tool out. And I'm going to add 12 to both sides. I'm left with p equals negative 1 over 40 x plus 22. And over here I have my b equals 22. I can say p equals negative 1 over 40 x plus, now I can plug in 22 for my b, and you see I get the same thing no matter which method I choose. And actually, if you do negative 1 over 40, I think you get 0.025, negative 0.025. That would be fine. If you're doing it with a calculator and you put it in that form, that's fine. Using a decimal is fine. I left it as a fraction because I knew I was going to be multiplying 1 over 40 times 400, or even 480. Still would have been easy to cancel that out, so that's why I left it. If you do decimals, you're fine. Okay. Hopefully that made sense. Go on to question 2, and restart the video once you've answered question 2. Okay. Economics, the word revenue refers to the amount of money that comes into the business. So it's the amount of money that you actually put in the cash register. It's not profit. It's different from profit. Profit we'll get into, but revenue is actually all the money that comes in before you even pay your expenses. So pretty easy to calculate if you're selling a product. When they were selling the bath beads for $400 or for $12 a piece, they sold them for 400. They sold 400 jars. That was $4,800. Just multiply 400 times 12. So you multiply the price times the number you sell to get revenue. It's the amount of money that actually comes in. Okay. So question 1, revenue is the number of units sold, X times price P. Question 2, write an equation that represents the revenue made on bath beads for your boutique owner by using the equation R equals XP. Then simplify your expression by multiplying out the parentheses using the distributive property. Okay. So we've got an equation for revenue, and we want to write an equation that write an equation for revenue, but we want it just in terms of x. We don't want the p there, is what they're asking. Equals x times p. So what we have to do is substitute in our expression from question 1, or our equation from question 1. We know we can calculate p based on x using that equation. So my p, the first thing I'm going to do is calculate p. by doing negative 1 over 40 times x plus 22. So that equation says I'm going to take my first equation, negative 1 over 40 times x plus 22, calculate my price, and then I'm going to multiply it by x. So now I have an equation for revenue where I have all of that in one equation. I don't have an equation for P and then an equation for R where I plug in P. I've plugged in the equation for P, or the expression for P. Question 3 is going to kind of build on that. So read the introduction and answer question 3, and then restart the video. All right, question 3. So we're starting to talk about costs. So we've got fixed and variable costs, which we've talked about before. Fixed cost doesn't depend on how much you produce. Variable costs are for things that are consumed in the production. So if you double your production, you double your variable costs. So fixed costs, things like rent, utilities, insurance, and wages. Variable costs are related to the number of things you sell. So for the boutique problem, the portion of the fixed monthly costs attributed to bath beads is $325. So that's the amount of money it costs to have those bath beads on the shelf. That's the amount of the fixed cost for the boutique that is actually assigned to the display location where the jars are. The boutique actually has more fixed costs than that, but it divides it up among the things that it sells. So to justify having the bath beads on the shelf, they have to make $325 a month to pay for the fixed costs. Cost of each jar of bath beads from the supplier is $350. So the boutique gets it at a really good price, sells it at a much higher price. That's how retail works. So write an equation then that represents the total cost C to the boutique of acquiring X jars of bath beads. Your equation should be of the form C equals MX plus B. And you'll notice here, for one thing, we don't have 4 numbers. We can't have 2 points because we don't have 4 numbers. But we've got dollars, which is really high, and then another dollars, which is really low. We actually know that the $350 is dollars per jar. So in this case, we're actually given the slope and the y-intercept. So we don't have to go through the steps that we went through in equation 1. It's a different kind of problem. We already have the information that we need. So we can just say C equals okay. So the equation now says however many jars you sell, we're going to have to multiply that by 350 to see how much we pay the supplier. We're also going to have to pay $325 for our fixed costs. That's going to be the cost of selling the jars. Okay. Question 4, I believe, starts talking about revenue and profit. So once you've answered question 4, restart the video and we can discuss the answer. So since revenue is the amount of money a business takes in, cost is the amount the business paid out, the difference is profit. So profit equals revenue minus cost. Revenue is how much you take in. You don't worry about paying anybody back. But to stay in business, you got to pay people back. So you take some of your revenue, pay your bills. What's left is called your profit. Write an equation that represents the profit made on bath beads by the boutique. So, hint, substitute your answers to question 2 and 3 in the formula P equals R minus C. Don't simplify your expression yet. Okay. So, P equals R minus C. We have an equation for revenue. We have an equation for cost. We're told not to simplify our equations yet. I'm going to go back to question 2. I didn't complete question 2. It says simplify your expression by using the distributive property. I thought we were going to do that later. But at any rate, to do the distributive property, a lot of people like to draw the lines. We multiply x times negative 1 over 40. X times x is x squared, and x times 22 is 22x. So that's a simplified form of that equation. Okay. I'm going to use that here. So negative, and I'm using it because it's simpler. I could have plugged in the other one, the first equation that we got without multiplying out the parentheses, but it simplifies things if I go ahead and multiply it out. Now I'm going to subtract my cost. And a lot of people will do minus 3.50x plus 325. But remember, if we're going to calculate cost, we need to subtract cost. We have to calculate it first. We have to calculate the cost by multiplying 3.5 times the number of jars sold plus the $325. We have to do that before we subtract. So we have to put that in parentheses. It is important to put those parentheses. Otherwise, you would subtract the 3.5x and then add the 325, which is different than calculating your cost and subtracting your cost. Okay. And that we're told not to simplify, so I'm not going to worry about those parentheses now. Okay. Go on to question 5 and restart the video once you're done with question 5. Cost consists of 2 distinct terms. Talked about that before, fixed cost and variable cost. And actually they're talking about, when they say terms, they're actually talking about these 2 things. Terms are things that are added or subtracted. But one of those represents the variable cost, the other represents the fixed cost. When we subtract, we need to make sure to subtract all of the costs, not just some of them. To make sure this happens, we put parentheses around the entire cost expression. And you'll notice they have anticipated a lot of people not doing that, so they say, if you didn't already do this, add parentheses to your answer from question 4. Then perform the subtraction, keeping in mind that the parentheses are there to remind you to subtract every term in your expression for cost. The resultant is an equation describing profit in terms of jars of bath beads sold. That's relatively easy to work with. Okay. So, P equals -1 over 40 x squared plus 22x. I'm going to say -1 times 3.50x plus 325. I'm really just copying the other equation to get started, but I put a 1 out here. I'm saying 1 times that quantity. 1 times anything is itself, so I don't change the equation when I say I'm going to take 1 times 350x, 1 times the quantity 350x plus 325. I'm also going to think of that as plus a negative. So instead of subtracting, I'm going to add a -1 times 3.5x plus 320. Now I'm going to multiply that, distribute that -1, just like I distributed the x before. You can think of it that way. In terms of the story, if we want to get profit, we have to subtract both costs. We have to subtract the fixed cost and the variable costs. A lot of people would just like to take out the parentheses and subtract 3.5x, but then they would be adding the fixed costs. You don't add the fixed costs, you have to subtract them, the same as you would subtract the variable costs. So now I go P equals -1 over 40x squared plus 22x minus 3.5x minus 325. So I end up subtracting the entire equation for cost. And when you think about it, if we did the cost, if we calculated the cost first, then we would subtract the entire cost. We would add the two costs together and subtract them both combined from the revenue. So instead of subtracting them both combined, instead of adding them first and then subtracting the answer, I subtract them individually. I'm still subtracting both of them. Either way, I subtract both costs. -1 over 40x squared. Now I combine like terms. I have 22 x's and I lose 3.5 x's. That gives me 18.50x minus 325. So I've gotten this equation down into what we call the simplest form. I just have two places where I plug into x. I don't have to do a lot of parentheses first. It's the quickest way to calculate profit. Okay? And you'll notice it's just profit in terms of number of jars sold. I don't have to calculate the price. I don't have to calculate the costs. I just plug in number of jars sold. Okay. We now have a did you get it? If you don't get it, figure out why. If you don't figure out why, let me know. I would be happy to discuss it with you. Okay. So, question 6, it goes on to ask some questions using that same equation, using the same story. So answer question 6, restart the video when you're done. So question 6, P equals negative 1 over 40 x squared. We're going to sell 200 jars plus 200 squared plus 22 times 200. I'm sorry. Plus 18.5 times 200 minus 325. So I plug that in. I'm going to go to the calculator now. Okay. So I do 1, and I push the negative sign, divided by 40 times 200 squared plus 18.5 times 200 minus 325, 2,375. Just double checking. Whoops, don't want to do that. 2,375. Find the profit made from selling 600 jars. So I can do the same thing. 1, make it negative, divided by 40 times 600 squared plus 18.5 times 600 minus 325, 1,175. I was a little concerned initially that my profit should have gone up, but if we think about it, we found that when we raise the price, or when we sell more jars, we have to lower the price. As we lower the price, we're making less per jar. We sell more jars, but we make less. So, and actually, I'm just kind of answering question 8, but go through question 8 yourself, then restart the video when you're done. So, making less money for selling more bath beads. To sell more, they need to lower the price. Okay. Question 9. What's the profit if the boutique sells no bath beads in a month? What does that result mean? So think about that for a moment and restart the video once you're done. You might have thought that the profit was 0, but actually and multiplying by 0 gives you 0, squaring 0 gives you 0. So the only thing you have is $325. Okay. What does that result mean? If you raise the price so much that you sell no bath beads, you still have to pay your fixed costs, is what that means. Try question 10. And see if you can answer that. Restart the video once you're done. So use computer calculator to graph the profit equation you wrote, and then use your graph to estimate the number of jars that must be sold to make the biggest profit. I'm actually going to go to Desmos.com. I think I just opened 3 web browsers. I'm going to start graphing. And I'm going to put in y equals negative 0.025 x squared. And with Desmos, you use the caret, which is shift 6 for your exponent, squared plus 0.5 x minus 325. And I'm going to have to zoom out to find my graph. And I'm seeing that one place it crosses the x-axis is the it's like 20 jars. You make 0 profit at 20 jars because you've raised the price so much that you only make $325. I continue to zoom out, and it looks like so I've got 20 and 550, 600, 650, 500, 600, 700, a little more than 700. I make 0 profit. And if you remember, about 600 is where I'm at 1750. So I got this point way up here, which appears to be a little less than 400. So I go 1,000 and 0. The maximum point is right about 400, and it's a little over 3,000. Actually, I'm going to say 3,100. So quick estimate on that. So estimate the number of jars that must be sold to make the biggest profit. 400 is a reasonable estimate. Anything close to that is going to be fine in terms of an estimate. We're just trying to get an idea right now. Go on to question 11 and restart the video once you're done with question 11. Okay. And that's 325. One negative divided by 40 times 100 squared plus 18.5 times 400 minus 325, 3,075. And on the graph, I had estimated the profit would be about 3,100. That's pretty close, only off by 25. So what selling price results in the largest possible profit? You'll have to go back to what we've done before to figure that out. We actually have an equation for that. So see if you can find that and restart the video once you've answered question 12. Okay, so selling price. So we had an equation where, I got to go back and look it up. Actually, if we started off with our price equals negative 1 over 40 times the number of jars plus 22, which is actually where a lot of the numbers that we've seen come in. So P equals negative 1 over 40 times, we want to sell 400 and plus 22. So that tells us the price that will enable us to sell 400, and that is actually, as we decided before, price equals $12. Go on to well, let's read through this and then we'll go on to question 13 after we read through this. So suppose that our boutique owner decides to donate the proceeds from 5 sales of bath beads to a local women's shelter each month. In that case, the revenue isn't x times negative 0.025x plus 22 anymore. It's x minus 5 times the quantity for price. So because the number of items that you will need to multiply by the price is 5 less. So we're going to give up the proceeds from 5 of those, or the revenue from 5 of those bath beads. So could we still use the distributive property to multiply out the parentheses? We surely can. Let's have a look. So we take 10 times this, 10 times this. Now we put the x minus 5 back where it belongs. Do exactly the same thing. So x minus 5 times and remember that negative 0.25 is the same as the negative 1 over 40. I'm going to take that whole thing now, the x minus 5, and multiply it by both of these. So I'm going to have x minus 5 times negative 0.025x. And we like to write, if we have something multiplied by parentheses, we like to write it on the left. So I'm going to write the negative 0.025x on the left side of x minus 5. Even though I'm doing x minus 5 times negative 0.025x, I can write negative 0.025x times x minus 5. Then I'm going to have plus x minus 5 times 22, but I'm going to write the 22 on the left. You'll see in the next step why I do that. Because now I have to take this whole thing and multiply it by both of these. I need to take my 22 and multiply it by both of these. So negative 0.025x squared minus, actually that's plus because now I have a negative 0.025x times negative 5. So if I'm subtracting a negative, I end up adding. 5 times 0.25 is 0.125x. Have my 22 times x plus 22x. And 22 times negative 5. So minus 22 times 5. Minus 110. Okay. Now I have two like terms that I can combine. Whoop. 22 plus 0.125 is 22.125x minus 110. And that was actually revenue. So we're taking this equation for revenue and multiplying it out. Okay. So go on to question 13 now. Actually, I think I may have done question 13 for you already. Looks like it. So multiply x minus 5 by the first term, multiply x minus 5 by the second term. Okay. Then you multiply that out, and then question 14 was actually the last thing I did, where you combine the like terms. So hopefully you understand that. If you don't feel comfortable with it, let me know. So multiplying multiple term expressions. Multiply two expressions that each have two or more terms. You have two choices. Treat the first expression as if it were just a number. Distribute to each other, and then you distribute over that one. Or you multiply every single term in the first set by every term in the second set, then combine like terms. Okay. So question 15. have to multiply an expression here. So go ahead and try that. See how you're doing with that. And once you get done with that, restart the video. We will talk about it. Okay. So you can do what you did before, what we did before. There's another way to think about this. So the parking lot, the 4-foot landscaping strip on 3 sides. An architect found that the total area could be expressed as W plus 4 times 2W plus 8, where W is the width of the paved portion. So multiply out the parentheses, this expression, and simplify. So I'm going to pretend that there's an area somewhere, a rectangle somewhere. And whenever we have multiplication, any multiplication problem could be an area problem. So I have W here and 4 here. So the left side and the right side of the big rectangle represents W plus 4. This length is W, this length is 4. When I add them together, I get W plus 4. And up here, I'm going to say 2W is this length, and 8 is this length. So the total length of the top is 2W plus 8. So this area represents this multiplication problem. So my total area equals W plus 4 times 2W plus 8. My individual areas, though, equal 2W times W. W times W is W squared. So the area of the upper left part of the rectangle is 2W squared. The area of the lower left is 4 times 2W, or 8W. The area of the upper right is also 8W because I multiply 8 times W. And the lower right then is 4 times 8. This is 4. This side is 8. The area is 4 times 8, or 32. And when I write it this way, well, first of all, I'm going to say that I can also write my area. I'll call this A. A equals W plus 4 times 2W plus 8, the total area of the rectangle. Total area of the rectangle is also equal to 2W squared plus 16W, because I have 8 W's and then another 8 W's, plus 32. So when we multiply out the parentheses, as we did it before, we would have gotten the same number. If I multiply W plus 4 times 2W and W plus 4 times 8, that's essentially what I did in my area model. I call this an area model. So this length was W plus 4. Here I am multiplying W plus 4 times 2W. So that would be like this. And here I am multiplying W plus 4 times 8. So I get to do it the same way. You will also notice As they said in the last panel, in the little discussion, you can also make sure you multiply everything in the first one. So I multiplied W times both of these. So that's W times 2W plus W times 8. And then 4 times 2W plus, actually most people usually do it on the bottom. 4 times 2W plus, I multiply my 4 times my 8, which is what I did here. So 8 times W plus 4, which is what I did here. So we can do 4 times 2W, give me 8W, 4 times 8, which is 32. A lot of times this is called FOIL. We do the first, outside, inside, and then last. But however you do it, you're going to end up with that form. Okay. Quick, did you get it? If you didn't get that, let me know. I'd be happy to discuss it with you. So now I have to do our classwork. So when we are adding or subtracting polynomials, we can really, adding or subtracting is really just like combining like terms is basically all that we do. So go ahead and try to do number 1. Restart the video once you're done. I rewrote this expression without the parentheses. The parentheses show me that I'm adding 2 polynomials. But when I'm adding, I don't really need the parentheses if all I'm doing is adding and subtracting. It doesn't make any difference whether I add the 3x squared and the 3x and the 5 and then add the 2x squared. I can add the 3x squared and the 2x squared and then add the 3x and the minus 3x. It's what we call the associative property and the commutative property. So I have moved them around. That's the commutative property. Now I'm going to associate them. Put the like terms together. I'm going to add the 3x squareds and the 2x squareds. Altogether, I'll have 5x squareds. And there's no reason for that to be x to the 5th. When we're adding, 3 times x squared means x squared plus x squared plus x squared. 2 times x squared means x squared plus x squared. If I'm adding 5x squareds together, I have 5x squared. That's the same as 5 times x squared. When I do 3x minus 3x, that's actually 0. So I would add 0. When you add 0, you don't change it, so I'm just going to leave the 5x squared. I'm not going to say plus 0. I am going to add in 5 minus 10. 5 minus 10 is negative 5. I'm going to add a negative 5, which is the same as subtracting a positive 5. Okay. Question 2 is a little more challenging. No, it's not challenging. You have to think a little bit more. So try number 2 and then restart the video. So on number 2, I have my 5x squareds. And as we saw earlier, if you're subtracting more than one thing, if you're subtracting parentheses, the parentheses say combine it all first and then subtract the one big number. We could add our costs together, our fixed cost and our variable cost, and subtract that one big number from our revenue to get profit. Or we could subtract each cost individually. Costs have to be subtracted, so we could take our revenue, subtract the fixed cost, and then subtract the variable cost. Or we could add the fixed and variable costs together and subtract them all at once. Subtract that big number instead of subtracting two small numbers. So as it says, we have to subtract everything. So I subtract x squared. If I were to subtract the negative 2x from my x squared and then subtract that answer, I would actually be subtracting a smaller number. So I'm going to subtract the negative 2x, which is the same as adding 2x, except that I forgot my 3x. So I have my plus 3x. Then I'm going to subtract a negative 2x or add a positive 2x. You get the same thing when you add a positive as when you subtract a negative. Now I'm going to add my 2, and then I'm going to subtract my 7. If I add the 7 to the x squared and then subtract, I would actually be subtracting both of those numbers. So I'm just going to do that. I subtract the x squared and I subtract the 7. And I'm actually subtracting a negative 2x as well. So I have 4x squared, because I'm going to do this first. I'm combining like terms. 3x plus 2x is 5x. And then 2 minus 7 is negative 5. So I add a negative 5 or I subtract a 5. Go ahead and try question 3. Restart the video once you're done. Question 3. Got a little more work to do. We've seen before that if we have a number times parentheses, we can get rid of the parentheses if we multiply the number times everything inside. Okay. Plus 2x squared minus 6x minus 20. So I have 3x squareds. I add 2x squareds. Gives me 5x squared. I have 9x. So 3x squared and 2x squared. I have 9x and I subtract 6x. I lose 6x's. I have 3x's left. I have 15 and I lose 20. So I owe somebody $5. Okay. So when we're basically doing two things. We have to distribute, then we combine like terms, or once we distribute, we combine like terms, and we're left with something that has no parentheses and no like terms. Simplify means get rid of the parentheses and combine like terms. So we have simplified the expression. Okay. Try simplifying the expression in question 4. Restart the video once you're done. So same thing. And you'll notice I have plus 15x because I'm multiplying negative 3 times negative 5. Okay. If you want to draw the lines as you do this, that's fine. 6x squared minus 12x squared gives me negative 6x squared. 8x plus 15x minus 10 minus 3. I subtract a total of 13. Okay. Looks like we got a did you get it? If you don't get it, try to figure out why. If you can't, let me know. We will discuss it some way. Okay. Question 5. You've probably already noticed that multiplying expressions is more challenging than adding and subtracting them. For that reason, we're going to get some more practice on multiplying and also develop a method to check and see if your result is correct when you multiply expressions. It also works for adding and subtracting, by the way. So perform each multiplication, keeping in mind that our procedure involves multiplying every term in the first factor by every term in the second factor. Restart the video once you've done question 5. So y squared plus 7y's minus 5y's gives me 2y's minus 35. Okay. 2 times 3 is 6. X times x is x squared. 2x times negative 8. I can multiply the numbers. Negative 8 times 2 is negative 16. And then I do 6 times 3x, which is 18x. And it's positive, so I'm going to add 18x. And then I do 6 times negative 8, which is negative 48. I've lost 16 x's, but I find 18 x's. I'm left with 2 x's. When I combine like terms. Okay. Multiplying everything by the second factor. Use the distributive property now in question 6 to multiply 2x times 3x plus 4. Does this match the description in question 5? Restart the video once you've answered that question. So question 6, 2x times 3x plus 4. Take 2x times 3x. Once again, that gives me 6x squared. Then I take 2x times 4 plus 8x. Okay. Does that match the description in question 5? It's kind of different. Question 5 was really, to think about it, I could do 2x plus 0. So I do 2x times 3x plus 2x times 4. Plus 0 times 3x. So plus 0x. plus 0 times 4 plus 0. 0 times x is 0. I would end up with 6x squared plus 8x. So if I wanted to think about it the same way, I could actually use the same process that I did before, but I don't have to. The way I did it initially, I multiplied every term in the left side times every term in the right side. 2x is just one term because there's nothing added or multiplied. So if I want to multiply every term times every term, the way I did it to begin with will work. Okay? Kind of an abbreviated version of FOIL, if you want to think of it that way. Okay. Go on to question 7. Restart the video once you're done. So if two expressions satisfy that condition, what should the relationship between their graphs be? Think about what the graph of an equation really is. So now about checking our answers. Earlier we pointed out that the goal when simplifying is to get another expression that provides the same exact output as the original, no matter what you choose. So if we look at two expressions, if we consider the expression to be an equation that says y equals this expression, we can actually graph that and see what the graph looks like. When we graph what we consider an equivalent expression, so y equals this equivalent expression, we should get the exact same graph. If we look at, if two things are equivalent, if they always give you the same answer, when you graph them, the graphs should completely overlap. Okay. So question 8, use a calculator or computer program to graph both. When you graph it, you'll have to say y equals 2x plus 6. You might try going to Desmos.com the way I did, times 3x minus 8. And I believe we found that that was the same as y equals 6x squared plus 18x minus 16x minus 48. So go to Desmos, see if you can get those answers, or see if you can graph those, and restart the video once you're done. I just realized you can't see what I'm doing. I'm just literally typing in that equation. Y equals 2 parentheses 2x plus 6. So I'm actually going to type the parentheses and then 2 and x from my keyboard plus 6, close parentheses. So I've initially graphed y equals 2x plus 6, and Desmos doesn't make me put the times. I can just put the parentheses together. So I'm going to do parentheses and 3x minus 8. Whoop. And to make it worthwhile, I really need to see what's happening with this equation. So I'm going to zoom in a bit, and you can click on the graph. I'm actually clicking on the plus to zoom in. You click on the graph and you kind of see Good thing to look at where it crosses the x-axis. And then the lowest point is actually down here about negative 48. In Desmos, there you can click on a second equation. And now I'm going to say y equals 6x. Okay, when I type my second equation in, I say y equals 6x squared. So I do 6 and then x. And shift 6 is usually the little caret that makes it do the exponent. And I put an exponent of 2. Plus 18x minus 16x is plus 2x. And then minus 6 times 8, which is minus 48. And it's now showing a green graph, which is on top of the blue graph. So when I take out the 8, so I essentially have a different graph. I still have my blue graph. The blue graph is the first expression. The green graph now covers it up. That's the second expression. So the second expression is directly on top of the first expression. This was the green expression. This was the blue expression. They were right on top of each other. So we know that what we did is correct. Our next goal is to multiply x minus 5 times the quantity x squared plus 3x plus 4. I'm going to use my area model to do that. You can do it with FOIL, but you can't do outside inside because there's 2 insides and it gets kind of complicated. You can use the arrows to point to different things, though. I like the area model. And you'll see why in just a minute. So I'm going to say there's a rectangle. One side has a distance of x squared plus 3x plus 4. The other side is x and negative 5. So if I do x times x squared, if I get this area here, that is x cubed. To do this area, I do x times 3x, which gives me 3x squared. In the final area, I do x times 4, which is 4x. Now I do my negative 5 to get this area. I do negative 5 times x squared. And you'll see that's similar to the 3x squared, which is just up and to the left. Negative 5 times 3x gives me negative 15x. And to get my last area, one side of that area is 4, the other side is negative 5. Negative 4 times negative 5 is positive 4 times negative 5 is negative 20. Now I combine like terms. This was 15x squared. And you'll notice I have negative 20. I have 4x and 15x. When I am combining my like terms, they kind of line up with each other. So 4x plus negative 15x gives me negative 11x. And then 3x squared plus negative 5x squared gives me negative 2x squared. and then I have x cubed. And that is all equal to x minus 5 times x squared plus 3x plus 4. So that's using the area model. That's how I did that. And actually, I just noticed they just wanted you to multiply x times everything. So multiply x times each term. That's actually what I did up here. I multiply x times each term in there. Question B, multiply 5 times each term. That's actually what I did here. So I didn't read the questions very carefully. Hopefully you read the questions better. Hopefully you stopped the video when you realized I was going on. But anyway, add all 6 products from parts A, B, and C, combining any like terms. That was what I did when I got this one right here. So the area model is a quick way to make sure you do all of the things that we're seeing you need to do. Right? Question 10 looks a little shorter. Hopefully I won't mess up question 10. Actually, I'm going to let you do question 10. Go to Desmos.com and see if you can figure that out. And actually, let me show you what Desmos.com looks like a little better. Okay. Any rate, go ahead and do that, and then there's the did you get it? If you don't get the did you get it, let me know. We can discuss it. And that brings us to the end of the lesson. So, as always, we don't do the technology. If you want to learn Excel, take an Excel class. That's the best way to learn it. 050 class is not the best way to learn Excel. Online practice is your ALEKS. If you don't do ALEKS, you probably will not pass the class. It is almost impossible to pass the class if you do not do ALEKS. So do lots of ALEKS. Do the applications which come later. And then submit them once I get a place on D2L for you to submit them. Let me know if you have any questions. Thank you for watching.